So now we're going to be doing question 5c, and this is a physical application of calculus question, also linked with the chain rule. So I'll read the question out for you guys. A hemispherical bowl of radius r centimeters is initially empty. Water is poured into it at a constant rate of k centimeter cubed per minute. Per minute. When the depth of the water in the bowl is x centimeters, v centimeters cubed of water in the bowl is given by v equals pi on 3 x squared times 3r minus x. Okay, so for the first part of the question, we're asking ourselves to show that dx over dt equals k over pi x outside of 2r minus x. All right, so as I said, we will be using the chain rule because, as you can see, we can't simply find a function where x is expressed in t here. So we're going to have to use the identity for I, that dx over dt is actually also equivalent to saying dv over dt times dt over dx. Okay, so how do we get these few values? Well, we know that the rate of which the volume is changing is given by a constant k centimeters cubed per minute. So we can straight away say that that is equal to k. So now we just need to find dt over dx. Well, as we can see, oh sorry, my bad. Those things should be dx over dv. Okay. Makes it a lot easier. Okay, so now we just need to find dx over dv. Well, we can find dv over dx if we differentiate this function, which is 1. So we'll just differentiate number 1 with respect to x. So we'll get dv over dx is equal to. So now we're going to have to use the product rule in this case for convenience. So we'll say the derivative of the first. So that'll be 2x pi over 3 times the second, which is 3r minus x, plus the derivative of the second, which is minus 1, and times the first, which is pi on 3 x squared. Now if we expand this, we'll get 2 pi x over 3 times 3r minus 2x squared pi over 3 minus pi x squared over 3. And this will give us 2 pi xr, because the 3's cancel out, and this will give us minus x squared pi. Okay, and we'll factor that out, and we'll say that is pi x over 2r minus x. Okay, so that's our dv over dx. So now all we have to do here is flip it because we want to reciprocate, because this is dv over dx, when in fact we want dx over dv. So we'll just flip it. And now we can use that in what we did here. So that, in fact, is now equal to which is the required result. And that's how you do part I. Okay, so now we've found that. We're going to be doing part 2 now. So this is a bit more tricky because we're going to be using variables that we know and the certain values that they're given by. Okay, so it says, hence show that it takes 3.5 times longer to fill up where x equals 2 over 3r, so when it's like up to here, as it does to fill where x is a third of the radius, which is down here. Okay, so we've been told that dx over dt equals k over pi x to r minus x. So since we want to know how long it takes, we want to find the function of t, because that's what we need to do. So because we can't integrate with respect to t, we're going to flip it one more time and say dt over dx, and make that equal to pi over k x to r minus x, which I'll expand out for convenience. So that's 2 pi r x, and then that's minus pi over k x squared. Okay, so now we can integrate this easily with both sides. So we'll say that t is equal to the integral of 2 pi r over k x minus pi over k x squared dx, and that equals pi r k x squared minus pi over 3k x plus c. Now we need to find the value of c, so what we know is that, as it told us, initially the bowl is empty, so at t equals 0, that's initially, x is equal to 0 because there is no water in the bowl, so obviously x should be equal to 0. Therefore, 0 equals 0 minus 0 plus c, and our constant is 0. Okay, so now we can use this. T equals pi r over k x squared minus pi over 3k x cubed. Okay, so now we just have to substitute when x is equal to 2 over 3r and 1 over 3r. So when x equals 2r over 3, we can say that t is equal to pi r over k for r squared over 9 minus pi over 3k 8r cubed over 27, and that equals 4 pi r cubed over 9k minus 8 pi r cubed over 81k. And then we can make that easier to read by multiplying this by 9, so we'll get 36 pi r cubed, 8 pi r cubed, all over 81k, which will give us 28 pi r cubed over 81k. So that's the time taken to fill it up to the 2r over 3. And now when x is equal to r over 3, we'll do the same process. So we'll call this t1 and we'll call this t2. So t2 is now equal to pi r over k r squared over 9 minus pi over 3k r cubed over 27, which is equal to pi r cubed over 9k minus pi r cubed over 81k, which again will do the same common denominator business. So 9 pi r cubed minus pi r cubed over 81k, which equals 8 pi r cubed over 81k. Okay, now the final thing we have to do is just compare the time. So when we compare things, we can observe the ratio they're in. So t1 over t2 will now be equal to 28 pi r cubed over 81k all over 8 pi r cubed over 81k. And now we can cancel out like 90% of this stuff. So that's all cancelled, that's all cancelled. So we're left with 28 over 8, which I believe is 3.5. Thus, we found that T1 is equal to 3.5 T2, so it is obviously 3.5 times longer to fill up to the 2/3 of the radius than it is to fill to the 1/3 of the radius.